Hi everyone, this is a question from Griffith and it's about harmonic oscillator problem on error function. So here the question says find the momentum space wave function phi p comma t in momentum space for a particle in the ground state of harmonic oscillator. Then what is the probability that a momentum of p on a particle in this state would yield a value outside the classical range for the same quantum energy? So first we have to find the momentum space wave function phi of p comma t for the ground state harmonic oscillator. So for that, what is the wave function of harmonic oscillator? Is psi naught, since it's the ground state wave function, x comma t is equal to m omega pi h cross 1/4, is it, e raised to minus m omega 2 h cross x square e raised to minus I E energy for ground state T by h cross, right? So this can be written as, if I replace E naught by half h cross omega, since it's the energy for ground state, m omega pi h cross 1/4 e raised to minus m omega pi h cross x square. So e raised to minus I e naught, if it is half h cross omega, h cross x cross will get cancelled, omega t half is that 2, right? So this is the wave function, ground state wave function. Now y p comma t is given by a constant factor 2 by h cross minus infinity to plus infinity. Then we will have a wave function in space, x space, multiplied by a factor e raised to minus I kx. Then we have in momentum space of dp, but we have to change this k in terms of p, since the integration is based on this p. So for that, 1 by under root 2 pi h cross minus infinity to infinity psi naught x comma t e raised to, we know that p equal to k h cross, is it? So p k by h cross. Then we have dp. Now we will be replacing psi naught with this wave function 2 pi h cross minus infinity to plus infinity m omega pi h cross 1/4 e raised to minus m omega pi h cross x square e raised to minus psi omega t by 2, and we have this factor, is it? So for this factor we will write e raised to minus I p x by h cross. Then last we have dp, sorry, because the space is not that much, equal to under root 1 by 2 pi h cross. We can take all the things out, m omega pi h cross to the power 1/4. Then we can take out this function even, so e raised to minus psi omega t by 2. Then we will be left with minus infinity to plus infinity, right? and then we have e raised to minus m omega pi h cross x square, then e raised to minus I p x by h cross, then we have dp, right? So for this integral we can write it like this: minus infinity to plus infinity e raised to minus ax square plus bx plus c dx, then we can write it under root pi by this e raised to b square minus 4a into c by 4a. So this is the formula. So here we can write it as 1 by 2 pi h cross, then we have m omega pi h cross 1 by 4 e raised to minus I omega t by 2. So now it's integral, so it is root pi by a. So here a is what? This term, is it? So we can write pi by m omega, sorry, how this is pi is 2, is it? This is 2, so here it is 2, here this is okay, anywhere here there is 2 here, right? So m omega by 2 h cross, so 2 h cross, now it's okay. So this is pi by a, then we have a e raised to b square. B square is this, is it? So b square is minus p square by h cross square, is it? Minus 4ac. So here our c is 0, is it? X square x, then we have a constant c, that term is 0, so that entire term is 0, divided by 4 into a, so 4 into this part, 4 into m omega by pi h cross, fine. Sorry, this is again I have written pi, it's 2, right? M omega 2 h cross. So this 2 pi h cross, 2 pi h cross will get cancelled out, and then you can write it as m omega pi h cross 1 by 4, and we will left with this under root m omega multiplied by I omega by 2, then here we can cancel out h cross, is it? 2 and 2 will get cancelled, so we left with e raised to minus p square divided by 2 m omega h cross. So this is our phi of p over t. This is the momentum space wave function, right? Now in that wave function, what you have to find? The probability that a measurement of p on a particle in this typical day will outside the classical range. So what we know is energy is given by p square by right, and p you can write it as under root plus minus 2 m e, right? So here ground state energy, so therefore plus minus under root 2m half h cross omega, right? So 2 will get cancelled, here will be plus minus m h cross omega. So this is our momentum. So they said it would yield a value outside the classical range, outside this range. Okay, now in order to find the probability, what we can write, minus infinity plus infinity, right? Then we have wave function in momentum space p comma t square dp, this will be equal to 1. Now since we have to find a momentum outside this energy, so we can write it as minus infinity to minus m h cross omega, right? Phi p comma t whole square dp plus the range is between this minus under root m h cross omega to plus m h cross omega under root, sorry. So this will be, that range will exclude it and will write plus m h cross omega to infinity, and we'll have the same phi in momentum space dp. So this can be written as, see now, we can write it as probability will be equal to 1 minus twice of, you can write it as 0 to m h cross omega, since total probability is 1. So we can exclude these two terms, these terms that are the range, then we'll be getting these two, is it? So this will be equal to 0 to m h cross omega, and it is multiplied by 2. So you can see this is 0, and there we have m h cross omega, and there we have minus m h cross omega. So this portion, and there we have minus infinity, there we have plus infinity. So this portion we have to exclude from total probability, because we want to find the probability that the measurement of p on a particle in this state would yield a value outside the classical range. So in this region we want, right? Then we have to exclude 1 minus this region, then we will be getting the other two region, right? So this is phi p comma t dp, right? So we need to find this first. If we find this first, we will get the probability, right? So let us take this. So let us take 2 0 m h plus omega. Now this is our wave. What is our wave function? This is our wave function, right? So here we can write m omega pi h cross 1 by 4. So this is a square, so this will be 1 by 2. Then we have 1 by m omega, and then the complex, since it is a complex conjugate, 5 star multiplied by 5, so that time these terms will cancel out and will be left out e raised to minus, here 2 is there, so because there is a square, a 2 will come in numerator, then that 2 and 2 will get cancelled, so we'll be left with p square m omega h cross, right? Anything left? No, right? So we can write it as 2, this will get 0 to under root m omega h cross, right? If this goes inside, then it will be under root, see, this can go inside, m square omega square, then m, the square will be cancelled and we will be left with m omega pi h cross, right? And then we have e raised to minus p square by m omega h cross dp. So now for solving this integral, first we have to substitute, right? So let p square by m omega a square equal to t square by 2 for convenience. Then we can write P equal to under root m omega h cross by 2 t, or differentiating this we get m omega h cross by 2 then dt, right? So now when p equal to 0, your t is also equal to 0, and when p equal to m omega h cross it, when p equal to this, then this t will be equal to under root 2, is it? When this p equal to under root m omega h cross, this 2 will cancel and t will be equal to root 2, fine. So now we can replace that integral. 2, this we have 0 because t is equal to 0 and t equal to root 2. If we replace, wait, let me write the same thing, m omega pi h cross multiplied by this e raised to minus this term, is it? We have to replace it by t square by 2, and we have dp. The dp we can write as this under root m omega h cross by 2 into dt. This will be equal to, so this m omega h cross will get cancelled and will be left with 2 multiplied by 1 by 2 pi, 1 by under root 2 pi. This will be 0 to under root 2 e raised to minus t square by 2 dt. So now here comes an error function. This is an, we have to solve it by error function. So in error function we have, suppose p to q e raised to minus x square dx. So if it is so, we will have under root pi by c multiplied by 1 by 2. Then we have error function, your upper limit q into root c minus error function, the lower limit into root c. So this is the formula, is it? Now we have this. So 2 into 1 by 2 pi. Now we will follow this. Your p is 0 and your q is root 2, is it? So under root pi by c, your c is what? 1 by 2, so it's 2 pi, right? Multiplied by 1 by 2, right? Next we have error function q. What is q here? Q here is root 2, so root 2. And what is root c here? Root c is 1 by 2, so root c is 1 by root 2, fine. Minus error function, here is how much? P. So p here is, I think, 0, so everything comes 0, right? Then here 2 pi will get cancelled, 2 will get cancelled. Now that term, that integral term is this, okay? Then you can write our probability that would yield outside the classical range is 1 minus error function, this root and root 2 will get cancel and we will get 1 minus error function 0, right? So therefore, and see here, for this error function value you have to see error function table from Google. So from error function table we have error function 1 equal to 0.8427 and error function 0 You can neglect it, it's very small, so we'll take it as 0. So we'll substitute. So probability that a measurement of P on a particle in this ground state would yield a value outside the classical region is 1 minus error function of 1 is 0.8427 plus 0. We have taken this as 0, so 1 minus 0.8427 is 0.157. So there is the probability that measurement of P of the particle in this state would yield outside the classical range, right? Thank you so much.